So as the start of this question suggests, dealing with CSI periodic table, we will be looking at trends on the periodic table to solve this problem. We have a list of elements here, and we need to figure out a way to identify which of those elements belong to either number 1, 2, 3, 4, or 5. So just want to do a quick little recap for us since we are dealing with the periodic table. There are two trends that we want to keep in mind as we work our way through this. The first one, as we increase from the left to the right, and as we go up a group, we're dealing with trends of ionization energy. We'll also be dealing with trends of electronegativity as well. So anytime that we're dealing with comparing elements of either ionization energy, electron negativity, we'll be looking at increases as you go left to right and then down to up. The opposite direction, when we increase going from right to left and then going down the groups, we'll be looking at trends of our atomic radius. So those are the three trends that we'll be utilizing for this particular problem here. For the first part, we're just going to take a look at one other piece of information from the periodic table, which happens to be our principal quantum numbers. So for clue number 1 that states that 1, 3, and 5 all have the highest principal quantum number of n equals 3, we know that n equal 3 is actually the third row. So any element in the third row that's in this list can be 1, 3, or 5. So taking a look here, I see magnesium is in this group here, I see silicon is in this group here, and I see sulfur is in this group. So all I know is that 1, 3, and 5 could either be magnesium, silicon, or sulfur. We haven't eliminated everything. We haven't eliminated anything yet, except for what 2 and 4 cannot be. So we need to go to the next part to figure out, well, how do we pare this down even further? The second clue states that criminal 3 is larger in size than criminal 1. So if I go back to that previous slide, I'm looking at my atomic radius trend, which means as I go from right to left, my atomic radius is going to get bigger. So if this is the case, then the trend I'm looking at, just looking at period number 3, looking at criminal 3 and 1, they're the group 3, they're the n equals 3 elements. So looking at the comparison, magnesium is far left, silicon's in the middle, and then sulfur is far right. So magnesium is greater than silicon, and that's greater than sulfur. Now this doesn't really identify us anything specifically, but we can remove some stuff. Criminal 3 is larger than criminal 1, which means sulfur can never be number 3, because sulfur is smaller than everything in that list. We could also use that logic to say that magnesium can never be number 1, because the criminal number 1 is the smallest, but magnesium in that list is the largest. Now I'm not using any other elements because since we're looking at criminal number 3 and criminal number 1, we know it could only be one of 3 different elements. So we've at least removed some information here. And as we go back, I just rewrote everything here to show, okay, we know the size comparison, but now let's look at the next trend, the next clue that states the first ionization energy of criminal 5 is greater than that of criminal 1. Going back, we know the trend for ionization energy goes from left to right as it gets bigger. So we'll be using that as it gets bigger. In 5 and 1, we're still dealing with magnesium, silicon, and sulfur. So we know from the atomic radius that magnesium is the greatest, but in terms of our ionization energy, magnesium is the smallest, and sulfur is the biggest. So from this information, we can start removing some more stuff here, because I know that magnesium can never be criminal number 1. So the only other options that I have here is that sulfur, I know that sulfur is greater than silicon, so which is true. The first ionization of 5 is greater than that of 1. So because sulfur is greater than silicon and magnesium, we know magnesium can't be 1, so we now know from this information element number 1 has to be silicon because of the way that this breaks down. And then when we keep going further, well, we already know magnesium can't be 1, sulfur can't be 1 now, a silicon can't be 3, So sulfur silicon means that magnesium is now number 3. And since magnesium and sulfur have already been identified, we now also can state that element number 5 is sulfur. So just by using those 2 middle clues here and always the first 3 clues, we know 3 out of our 5 suspects. And we can use what we know about element number 3 for the last 2 clues. So for this clue, since we know magnesium is number 3, criminal number 4 is in the same group, which is the vertical column, as criminal number 3, but less electronegative. So we're looking for that electronegativity trend, and we know that as we go up a group, your electronegativity increases. So we're looking for something smaller. So when we look at electronegativity values, our beryllium is actually greater in electronegativity than magnesium, which is greater than in electronegativity than calcium. So we only care about the comparison to number 3, so we now know that number 4 is going to be calcium. So we now have eliminated 4 of our 5 clues, and the last thing that we have to look at is the last one, which is not really a trend, but it's just how do we deal with electron configurations. So since element number 3, so criminal number 3 is magnesium, I can write out what its electron configuration is. 1s2, 2s2, 2p6, because remember, it's in the third, it's in the highest principal quantum number is in the 3rd row, and it's actually located as the 2nd element in. So this is the electron configuration for magnesium, but if we want to lose 2 electrons to get that positive 2 ion, then that means that magnesium 2 positive is simply 1s2, 2s2, 2p6. But this now is also equal to some unknown element with a charge of -2. See, if you read that clue one more time, it says the -2 ion of criminal 2 has the same electron configuration, which is 1s2, 2s2, 2p6. So if I lose 2 more, then my neutral element X will have an electron configuration of 1s2, 2s2, 2p4, which will have an atomic number of 4 plus 2 plus 2, which is 8. So we're looking for an atomic number of 8, which happens to be oxygen. So when we go through and organize our answers, criminal number 1 is going to be silicon, criminal number 2 is going to be oxygen, 3 will be magnesium, 4 will be calcium, and 5 will be sulfur.